In this video, we'll look at the factors that affect the amount of products formed during electrolysis. So there are three factors that affect the amount of product formed, and they are the charge on the ion, the current applied, and the duration of the electrolysis. So we can use this equation here, Q equals IT, where Q equals coulombs, I is current, and T is time in seconds. Let's look at charge on the ion. Let's compare SN2 plus and SN4 plus. If equal current is passed through solutions containing the above two ions for the same amount of time, which will produce the greatest amount of product? Well, SN2 plus requires 2 moles of electrons to form 1 mole of SN. SN4 plus requires 4 moles of electrons to produce 1 mole of SN. So if you pass the same current for the same time, then SN2 plus would produce twice as much product, or SN4 plus would produce half as much. And the reason is the SN2 plus requires 2 moles of electrons, and SN4 plus requires 4 moles. Let's look at an example. A 40 amp current flowed through molten iron chloride for 10 hours. Determine the mass of iron and the volume of chlorine gas, and this is at 273 K in 1 atmosphere pressure that is produced during this time. So you can use Q equals IT, and you can use this information here. 1 mole of electrons equals 96,500 coulombs. So you can try this now. The answer is coming up next. And here it is. So you start with Q equals IT. The current is 40 amps, and the time in seconds, don't forget, is 36,000. That equals 1.44 times 10 to the 6 coulombs. Then you look at the half equation. So Fe3 plus 3 moles of electrons makes 1 mole of iron. So it's 3 moles of electrons to 1 mole of iron. Chlorine, on the other hand, requires 2 moles of electrons. So it's 2 moles of electrons equals 1 mole of chlorine. So let's calculate the moles of iron. It's 1.44 times 10 to the 6 divided by 3 times 96,500. It's 3 because we need 3 moles of electrons. And that gives us 4.97 moles of iron. And then we multiply number of moles times molar mass to give us 277 grams of iron. And this is the chlorine. It's 1.44 times 10 to the 6 divided by 2 times 96,500. That gives us 7.46 moles of chlorine. And we multiply by 22.4, which is the molar volume of a gas, right? And we get 167 decimeters of chlorine. Next is electroplating. So here's the apparatus to use if you want to electroplate something. On the left we have the anode, which is the metal that you want to plate with. On the right we have the cathode, and we want to coat this spoon with silver. Okay, so you have a battery, and the flow of electrons is from anode to cathode. The anode, the silver piece of silver here, that's going to be oxidized, because oxidation happens at the anode and reduction happens at the cathode, so the spoon will become coated in silver. The cathode is the item to be plated. In this case, it's the spoon. The anode is the metal you want to plate onto the spoon. The silver anode is oxidized. The silver ions are reduced onto the spoon, and the spoon is coated in silver.